Welcome to the Knowledge Lab. Fuel your mind with science. Imagine you're running late for work. You see the elevator closing, the stairs are jammed, and then, without hesitation, you walk straight through the wall. Sounds like science fiction, right? But in the strange world of quantum mechanics, that might not be as impossible as it sounds. Welcome to Knowledge Lab, the channel where science bends reality and curiosity leads the way. Today, we're diving into one of the strangest, most mind-blowing phenomena in quantum physics. Quantum tunneling. Is it just a microscopic quirk? Or the key to walking through walls and even teleporting someday? Let's start with the basics. In our everyday life, if you hit a wall, you stop. Physics 101, right? But particles at the quantum level don't follow the same rules. In quantum mechanics, particles like electrons don't exist in one place. They behave like waves spread out in space. These waves represent the probability of where a particle could be. Now here's where it gets weird. Let's say an electron is trapped in a box with a wall it shouldn't be able to cross. Based on its energy level, classically it would bounce back. But quantum mechanically, there's a chance, however tiny, that it tunnels through the wall. It's as if the particle disappears on one side and reappears on the other, without having the energy to climb over the barrier. It's like throwing a tennis ball at a wall 1,000,000 times, and on the 1,000,001st try, it magically ends up on the other side. That's quantum tunneling. Okay, cool. Electrons can do party tricks. But can we? Can humans, made of trillions of atoms, ever tunnel through walls? Let's do some math. The probability of a single particle tunneling through a barrier is already very small. When you scale that to trillions of atoms all needing to tunnel at the exact same time, the odds become astronomically low. We're talking less likely than winning the lottery 1,000,000,000 times in a row. But never say never. Science has shown us again and again that today's impossibilities can be tomorrow's breakthroughs. 100 years ago, quantum tunneling was just a theory. Today, we use it in real-world technologies like semiconductors, tunnel diodes, scanning tunneling microscopes. Yes, we've turned this strange phenomenon into tools that power your phone and help us see individual atoms. So while you can't walk through walls yet, we already manipulate tunneling in technology. Still skeptical? Let's look at where tunneling is already changing our world. The sun literally wouldn't shine without quantum tunneling. The fusion process at its core, where hydrogen atoms become helium, requires protons to get extremely close, overcoming a strong repulsive force. Classical physics says it shouldn't happen, but quantum tunneling allows it. Scanning tunneling microscopes work by measuring the tunneling current between a sharp tip and a surface, allowing us to visualize individual atoms. Modern transistors and microchips, especially in quantum computing, are exploring tunneling as a method of ultra-fast, low-energy data transfer. So while it might seem like a sci-fi fantasy, quantum tunneling is already shaping the future. Now here comes the fun part. Teleportation. Can quantum mechanics allow us to vanish here and reappear there? Short answer, kind of, but not in the way Hollywood shows. We've already achieved quantum teleportation, but only with information, not people. Scientists have successfully teleported quantum states of particles from one place to another using something called quantum entanglement. Think of it like this. Two particles are entangled, linked across space. Change one, and the other changes instantly, no matter how far apart they are. In 2017, researchers even teleported quantum data between Earth and a satellite 1,400 kilometers away. But teleporting a human, that would require mapping out the entire quantum state of every atom in your body, about 10 subular 28 atoms, and recreating it elsewhere. Not impossible, just incredibly complicated and ethically terrifying. Would the original you be destroyed? Is the teleported version still you? These are the kinds of questions that push the limits of science and philosophy. Here's a crazy twist. Some interpretations of quantum mechanics, like the many worlds theory, suggest that every quantum event creates new parallel universes. So when a particle tunnels through a wall in one universe it does, in another it doesn't. What does that mean for us? It suggests that reality is a probability cloud, not a fixed line. It means that you, as a macro collection of particles, have a non-zero, but nearly impossible, chance of quantum tunneling. That somewhere in some bizarre alternate universe, you did walk through that wall. So, where does this leave us? Are scientists working on quantum tunneling tech to walk through walls? Not directly, but quantum mechanics is paving the way for quantum computers, quantum communication, tunneling transistors, nanoscale devices that break classical limitations. Some futurists even imagine machines that could manipulate quantum probability fields, reducing barriers or even simulating teleportation. Buff Gasarib. If we learn to control the probability wave of particles, we might nudge matter through obstacles. Maybe not in 10 years, but what about in 100 or 500? So, can you walk through a wall right now? No, but is it forbidden by the laws of physics? Also, no. Quantum tunneling is not a fantasy. It's a fundamental part of nature. We just haven't figured out how to scale it. But give science time. Today, tunneling is in your electronics. Tomorrow, it could be in your travel plans. Reality has always been stranger than fiction. And in the quantum world, it's downright mind-bending. So next time you look at a wall, don't just see a barrier. See a possibility. Until next time, this is KnowledgeLab. Keep questioning reality.